So now let's focus on reactions of alkenes, specifically reactions and how we make an alkene. Now in this case, what we need are two halogen atoms sitting either on the same carbon or next to each other. So in this case, I've drawn two Cl sitting on, just basically be 1,1-dichloropropane. We could also put the chlorine over here on the other side. It doesn't matter, because what we're going to do are two elimination reactions, and we're actually going to have to do this in two steps. The reagent here is NaNH3, and this is made by taking sodium metal and putting it in contact with ammonia, and this is going to abstract a hydrogen to give us the N2- ion. The N2- ion is an incredibly good base, and what it's going to do is it's going to pluck off hydrogens from this alkane. Now, alkanes are not very acidic, so the base we're using here, the NaNH2, is super aggressive. And it is so aggressive that we're going to have to do this completely air and water free. If there is any air or water, we're going to form NH3, the ammonia, and sodium hydroxide. The solvent here is NH3. Now, the big distinction we're going to make here, you're going to see why in a later video, there is no sodium metal present. If we have sodium metal present, we're actually going to get a different type of reaction. So we're going to make the NaNH3 plus to make sure that we don't have any sodium in a zero oxidation state. And our first step, as you might expect, is attack of this ion against the hydrogen to produce our alkene. Now, alkenes are more acidic than alkanes, and when I say acidic, I mean relatively speaking. We are not going to produce H plus in water. But since this NH2 ion is so effective at removing a hydrogen from an alkane, it's going to be super effective at removing a hydrogen from an alkene. So our second step in the mechanism is abstraction of another hydrogen. We get attack, collapse, and we get NH3 and NaCl. Now, note on this, alkynes are more acidic than alkanes. And so if we do end up having a hydrogen here, our next step is actually abstraction, and we can't stop this with the NaNH2, and so we actually end up forming this ion, or this organometallic complex. So if we want to create the alkene, the last step we have to do is that this is step one. Step two is the addition of water. So really this is what we're finishing up with. And then we do a water as a polishing step to put the hydrogen back onto the end of the carbon triple bond and give us sodium hydroxide, which should hopefully be something we can easily separate out. So if you want to form an alkyne from a double halogenated compound, and again, they can either be vicinal or geminal, all you need is NaNH2 taken by mixing ammonia with sodium. You want to keep the sodium separate. Again, we'll talk about later video why you want to do that. Run the reaction, and then as a second step, add water. And the water is going to reprotonate the alkyne to give you what you want to make and produce sodium hydroxide, which in principle you can extract back off. So this is how we make alkynes from double substituted alkanes.